Okay, we're continuing with the Algebra 2 homework, the review for Chapter 2. And at this point, we get to a point where we have graphing inequalities. What makes them inequalities? It's this symbol right here. The greater than or equal to, less than or equal to, greater than. Those are all inequality symbols. And so that means that you're not only going to have the line or the V shape, but you're going to have shading. So let's identify what kind of graphs these are. First of all, this one, since it doesn't have an X, it only has a Y. This one is a horizontal line. That's the type of boundary it will have. This one right here is a slanted line. Okay, it's going to have a slope of 3 and a y-intercept of 1. So this one's also it's also a line. Okay. This one right here, it's going to be a V shape. It's going to open downward because of the negative. And this one's a V shape and it's going to open upward. So let's start with the first one. Graph the inequality y is greater than or equal to -2. So this is just like graphing the line y equals -2, which is a horizontal line through -2, which means that it's just going to be a line that goes straight across through -2. The difference is, because of this inequality symbol, we need to make sure that it's shaded. Now, when I look at these ones right here, if I have a less than or a greater than, then my boundary line between the shaded and non-shaded is going to be dashed. If I have less than or equal to, greater than or equal to, the boundary line is going to be solid. It's kind of like when we are on a single one-dimensional or two-dimensional line. It was open circle versus closed circle. It's open line versus closed line. Okay, so let's go back to this graph. I do need to have a solid line because I have greater than or equal to. And now you test a point. The best point to test is the point 0, 0. The only time you can't test 0, 0 is if it goes through 0, 0. But we're good here. So we're going to test 0, 0. You test it in this inequality. So here, let me just turn that into it. In other words, if I plug 0 in for x, oh, there's no x. Plug 0 in for y, right there. Is this true or false? 0 is greater than -2. True. You shade the side that's true. So this right here is true. So everything on this side is going to be true. Alright, so you shade this whole entire area, because everything up here is going to be true. Now you can pick any point on this whole space, but 0, 0 is the easiest one to pick. Okay, let's go to the next one. Now we already talked about this is going to be a line. Unlike the other one, this is going to have a dashed line. Okay, so we got to remember that, dashed line. We don't want to get a solid line, a dashed line. And then it's a line, so we're going to graph it using slope and y-intercept. So the y-intercept is +1. And the slope is 3, meaning 3 over 1. So from this point, up 3 over 1, up 3 over 1. Okay, unlike a V shape, it doesn't go back up this way. It's just a line. So it's going to go back down this way. Okay, now I would go and get my line maker, but it's not supposed to be a line. It's supposed to be a dashed line. So I'm going to have to do the best I can to try to make a straight dashed line here. So here's my attempt at a straight dashed line. Okay, and then I need to decide which side to shade. Now 0, 0 is just barely on that side, but it's okay. As long as it doesn't go right through 0, 0, you can use 0, 0 as a test point. So I'm going to plug in 0 for x and 0 for y and see if it's true or false. So I plug in 0 for y and plug in 0 for x. Work out both sides of the inequality and see if it's true. So 3 times 0 is 0 plus 1. So that's 0 plus 1. And is this true? 0 is less than 1? Yes. So because it's true, that means the side that includes 0, 0 is the true side. So I'm going to, 0, 0 is the true side. So it's everything over here. Now I think somewhere in your book it probably says something about the fact that the reason why it's here is it's below the line. I mean, if you look at it, all these are also below the line, and it's y is less than, and less than means below. But I caution you in doing that because that's only if it's in slope-intercept form. It's best to always test a point. Okay, let's go to the next one. This one's an absolute value graph and is an inequality. So it's going to be a V shape and it's going to have shading. It's going to have a solid line. All right, solid because it has the equals part. To graph an absolute value graph, we need to first find the vertex. The vertex of this absolute value function is 5, 0. That's positive 5, 0. We did that in the other video. And the slope is going to be 1. It's going to be up and down 1 over 1, but it's going to open downward because of this negative right here. Okay, so I'm going to graph the vertex, 5, 0. It's going to have slope of 1, but opening downward, so down 1 over 1 in both directions. Okay, now what kind of line are we going to have? We're going to have solid lines, so I can go get my line maker. Thank goodness, there we go. And it makes that line. Now, we have to decide which part to shade. Should we shade above the V or below the V? And we're going to pick a test point. I love to pick 0, 0. That's the best one to pick. So test 0, 0 in this equation, or inequality. So it was y is less than or equal to negative absolute value of x minus 5. But what we're going to do is we're going to substitute in, instead of x and instead of y, we're going to substitute in 0 and 0. So 0 is less than or equal to negative absolute value of negative 5. This negative doesn't cancel out. You've got to chop off the sign of the 5 next and then apply this. So this is 0 is less than or equal to negative 5. Is that true or false? 0 is less than a negative? No, zeros can't be less than negatives. So this is false. So because this is false, that means everywhere over here that includes 0, 0, this whole region is false. The only part that's true is down here, the part away from the 0. So if the 0 is false, you shade the part away from it. If the 0 is true, you shade the part that includes it. Okay, we have one more. This absolute value graph, it's going to have a dashed line, so we can't forget that. Dashed line, and you know what? We are going to cross this one out because we didn't talk about graphing ones that have a coefficient inside. So you don't have to do that problem. Okay, let's go to this review. The things that are going to be on the upcoming test, there's several different things. This has been kind of a long chapter, okay? These are all the things. First of all, you need to be able to represent relations, order pairs, graphs, mappings. You know what a mapping is? It's that thing where it's like it's got the two circles and then you have like the different arrows going. All right, you have to determine whether a relation's a function, like vertical line test. You have to evaluate f of x. You got to be able to find the slope using the slope formula. Got to be able to find the slope from an equation. Got to be able to find the x and y intercepts. Got to be able to write an equation of a line given a point and a slope, in other words, point-slope form, or rewrite it in slope-intercept form, or rewrite it in standard form. You're also going to have to know the difference with slopes between parallel and perpendicular, and then write equations that are parallel and perpendicular. You're going to have to be able to graph lines using slope and intercept, graph lines using x and y intercepts, that's this 0, 0 table, graph horizontal and vertical lines. Remember, horizontal is y equals something, and vertical lines are always x equals something. All right, and then the last part, you're going to have to be able to draw scatter plots and identify correlation, do the best fit line equation using the calculator, that's the lin reg. Use the equation of the best fit line to make predictions. That's just where you plug the x back into the equation you found. Graph absolute value functions using transformations. That's what we did earlier. Write equations for absolute value graphs. We did that in an earlier video too. And then this is what we just did right now. Graph linear inequalities and absolute value inequalities. What makes them inequalities? It's the less than or greater than. Determine whether the boundary line should be solid or dashed, and which side to shade. And we talked about that in this video.